We are studying signals and systems, and today we'll discuss about the Fourier transform. इसके प्रीवियस लेक्चर में हमने Fourier सीरीज के बारे में पढ़ा है। अभी Fourier सीरीज कन्वर्ट अ टाइम डोमेन सिग्नल टू फ्रीक्वेंसी डोमेन, है ना। हमारे पास जो फ्रीक्वेंसी स्पेक्ट्रम ऑब्टेन हो रहा है Fourier सीरीज यूज करने के बाद, वो है मैग्नीट्यूड ऑफ Cn वर्सेस ओमेगा और एंगल ऑफ Cn वर्सेस ओमेगा। अभी ऑलरेडी हमारे पास Fourier सीरीज है, एक मैथमेटिकल टूल है सिग्नल एनालिसिस के लिए। देन व्हाट इज द नीड ऑफ Fourier ट्रांसफॉर्म? ओके, so I will tell you Fourier series is only for periodic signals. Fourier series, it is for periodic signals. Okay? एक ऐसा सिग्नल जो रिपीट करता है खुद को, x of t is equal to x of t plus t naught. t naught क्या है? इट्स अ पॉजिटिव रियल नंबर। अगर कोई सिग्नल पीरियोडिक नहीं है मतलब नॉन पीरियोडिक है। ओके, सो हाउ टू डिफाइन द नॉन पीरियोडिक सिग्नल? नॉन पीरियोडिक सिग्नल, if this is not true, x of t is not equal to x of t plus t naught. Okay, t naught is a positive real number है, and the signal is not repeating itself. Okay, means what type of signal it is? This one. ये सिग्नल जो है not repeating itself, so minus tau by 2, 0 और plus tau by 2, a and x of t. This signal is not repeating itself. इसका और एक एग्जांपल हम ले सकते हैं। तो नॉन पीरियोडिक सिग्नल 0, okay, let us say 1, minus 1, a and this one, triangular function. Okay, so this signal is a non-periodic signal or it is called band limited signal. To analyze this signal, okay, what is meant by analysis? हमें ये टाइम डोमेन सिग्नल का फ्रीक्वेंसी डोमेन रिप्रेजेंटेशन ऑब्टेन करना है। ठीक है, इट मीन्स दिस सिग्नल इज मेड अप ऑफ डिफरेंट फ्रीक्वेंसीज, है ना, एंड दैट फ्रीक्वेंसीज इज हैविंग डिफरेंट एम्पलीट्यूड्स। तो कितने एम्पलीट्यूड्स है उसमें, कौन से फ्रीक्वेंसी के कैसे पता चलेगा? इसको ऑपरेशन करने के बाद। व्हाट इज मीन बाय ऑपरेशन? ऑपरेशन मीन्स एनालिसिस। Okay, analysis. What analysis do? It converts a time domain signal to a frequency domain signal or to a frequency domain signal. How to represent this? We'll see. Okay, तो अगर हम रिवर्स चाहते हैं frequency domain to time domain, it is called synthesis process. Okay, so that is called reverse Fourier transform or inverse Fourier transform. Okay, so let us talk about the Fourier transform first. Now one thing is clear, x of t जो है, okay, x of t is a band limited non-periodic signal or aperiodic signal. X of t is non-periodic signal. What type of signal it is? We are using notation t, that it is continuous time period non-periodic signal. Fine. Now Fourier transform of this, Fourier transform of x of t, okay, we have to express by using the Fourier transform equation. So it is written as f, okay, operator Fourier transform x of t. किसका Fourier transform फाइंड कर रहे हैं? x of t का। okay, हमें क्या मिलेगा? Fourier transform मिलेगा, मतलब x of j omega, okay, x of j omega, or you can call this as x of omega also, but you have to remember, okay, what is the meaning of that, and it is equal to integration or minus infinity to plus infinity x of t. okay, ये सिर्फ सिग्नल है, इट इज अ नॉन पीरियोडिक सिग्नल और इसका हम फ्रीक्वेंसी एनालिसिस करने वाले हैं, we have to find this signal. So it is under integration. Okay, it is e raised to minus j omega t dt. Okay, so exponential, complex exponential e raised to j omega t है ना. तो this term, ये जो term है, this one, so this term or this term, okay, this term is a complex valued function, complex valued function, or it is complex valued variable. X of j omega complex क्यों है? Because presence of j tells that it is a complex valued function. Okay, simple notation में हम इसको x of omega बोल सकते हैं. ठीक है, तो अब ये जो है complex valued function है, मतलब क्या है? It is having real part and imaginary part. Okay, it is having real part and imaginary part. Okay, we have to find it. पहले हम फूरियर ट्रांसफॉर्म का इक्वेशन ऑब्टेन करेंगे, देन विल कंपेयर विद द फ्रीक्वेंसी स्पेक्ट्रम ऑफ फूरियर सीरीज. तो आपको डिफरेंस पता चलेगा फूरियर ट्रांसफॉर्म क्या है और फूरियर सीरीज क्या है. ओके, सो we'll demarcate using the equations and their magnitude spectrum. Fine. So x of omega जो है, it has magnitude and phase spectrum. Okay, so how to find magnitude of x of omega? We have to find magnitude. Okay, so it is written as mod of x of omega. It means we are finding magnitude, and it is, इसका जो real part है, we'll call this as xr, okay, square of omega plus xi जो है square of omega. Okay, what is xr square? xr square is, this one is real part of x of omega, and this one is imaginary part of इस चीज का x of imaginary part of x of omega. Okay, now अभी भी we don't have the exact value of x of omega. Okay, फूरियर ट्रांसफॉर्म फाइंड करने के बाद हमें जो भी आंसर मिलेगा उसमें रियल टर्म है और इमेजिनरी टर्म है. हाउ टू आइडेंटिफाई द रियल एंड इमेजिनरी टर्म? ओके, फॉर एग्जांपल हमें x ऑफ ओमेगा कुछ इस टाइप का मिल रहा है, 2 प्लस, है ना. ओके, या फिर लाइक दिस वी आर गेटिंग, so it is 1 divided by 2 plus j omega. We are getting like this. Okay, so this part, ये जो 2 है, so this is what? xr of omega. Okay, it is real part of this one, and this one omega, okay, only omega जो है, so this part is xi of omega. मतलब जो भी j के साथ प्रेजेंट है, it is called imaginary part, और जो भी ये टर्म है बिफोर प्लस और माइनस, it is called real part of omega. Okay, we have to substitute these values here. We can find the magnitude of x of omega. ठीक है, अभी इससे क्या मिलेगा हमें? इससे क्या मिलेगा? इससे मिलेगा हमें मैग्नीट्यूड स्पेक्ट्रम. ओके, इससे मिलेगा हमें मैग्नीट्यूड स्पेक्ट्रम. ओके, व्हाट इज मैग्नीट्यूड स्पेक्ट्रम? मैग्नीट्यूड ऑफ x of omega versus magnitude of x of omega versus omega itself is called magnitude spectrum. Means what we'll get? We'll get a graph, a plot. Okay, this is magnitude of omega, magnitude of x of omega, okay, 0 and it is minus omega. So this is called magnitude spectrum. Okay. What type of magnitude spectrum we'll get? We'll get continuous time. We'll get x of omega जो है हमें we'll get the continuous like this. Okay. अभी क्वेश्चन ये है कि where it starts and where it ends. Okay. Why we are getting like this? ये हमें कब समझ में आएगा? When we'll compare this with Fourier series. Okay. In Fourier series we have different type of magnitude spectrum और यहाँ पर हमें different मिल रहा है. Okay. So this range जो है, so this is minus pi to plus pi. Okay. एक तो ऐसे आएगा. Otherwise, if you shift this to the right side, it will go from 0 to 2 pi. Okay. Minus pi to pi is a 2 pi. Okay. So this is the range of omega, है ना? So omega का जो range है, so it is written as omega is a 0 to 2 pi. Is the range of omega. And what is omega? So we have omega is 2 pi by t. 2 pi by t. So what is t? T is the fundamental time period. T is fundamental time period of signal, जो कि Fourier series में periodic signal का time period था. यहाँ पर हमारा time period है. Okay. So this is the base band signal. It is having इसका जो time period है, it t tends to infinity है. Because of that, it is going to continuous function. X of omega is a function of omega. ठीक है. So if we shift like this, ये जो graph है omega, okay, if you plot like this 0, it is magnitude of x of omega. Okay. If you sketch from this 0, अगर यहाँ से sketch करोगे, so this will be like this. So this is 2 pi. Okay. Whether right and left side, or you can sketch on the right side also, magnitude spectrum. So this is about the magnitude spectrum. So at what frequencies? Okay. So what you are doing? We are changing. Okay. Changing frequencies omega. So omega is equal to 0. Okay. Pi by 2, pi. Okay. 3 pi by 2 and 2 pi. So what is the x of omega? ये जो है इसका magnitude हमें obtain होगा and we can plot this spectrum. This is the magnitude spectrum. Now talk about the frequency spectrum. हमें दो spectrum मिलेंगे, frequency and magnitude spectrum. Sorry, okay. All together it is called frequency spectrum. Magnitude spectrum plus phase spectrum. So this is our phase spectrum. हमें जो second graph मिलेगा वो मिलेगा phase spectrum का. Okay. अभी how to find the phase of this? So the phase angle is denoted by this one, x of omega versus omega. So this plot is called as phase spectrum. Okay. अभी जो exponential function है हमारा, okay, I will show you. हमारा जो x of omega का equation है, x of omega is equal to integration for this limit x of t e raised to minus j omega t dt. Okay. अब ये जो term है exponential term, this one. So this term can be represented using trigonometric notation. कैसे? By using e raised to minus j theta, है ना? ये Euler's identity है, Euler's formula है, so it is cos theta minus j sin theta. इसको हम यूज करके कैसे लिख सकते हैं? e raised to minus j omega t is equal to cos of omega t minus j sin of omega t. Okay. It means, so this omega is a angular frequency and this represents the cosinusoidal and sinusoidal components and represented using exponential form in Fourier transform. Okay. हमने will similarly discussed about the Fourier series also, sum of exponential functions. Fourier series जो है ना, so any signal is built or can be constructed, okay, or it consists harmonics, है ना. So same here, omega changes and these components changes, okay. So come back to our phase spectrum, okay. phase spectrum जो है हमारा, देखिए फेज स्पेक्ट्रम जो है ना, वी हैव टू फाइंड द फेज फर्स्ट ऑफ ऑल. सो एंगल ऑफ एक्स ऑफ ओमेगा इज कैलकुलेटेड एज tan inverse of imaginary part of x of omega divided by real part of x of omega. ये जो है ना, इससे हमें क्या मिलेगा, फेज मिलेगा. And thereby we can sketch the phase spectrum. We'll sketch the phase spectrum, okay. So we'll draw a small diagram. So this is angle of phase, angle of x of omega versus omega. So it is minus omega. Fine. Now according to the value of omega, we'll get the different values, है ना. So we'll get graph like this depending upon the value of x of omega. Here just we are representing the what is phase spectrum. It is the angle of x of omega versus omega is the phase spectrum, okay. When actually solve the example, we'll get some values and we'll sketch the magnitude and phase spectrum, okay. Now come to the discussion of Fourier series and Fourier transform, okay. Comparing Fourier series and Fourier transform. What exactly is the difference between these two? Fine. तो हमारा जो Fourier series है, we have exponential Fourier series. Exponential Fourier series. What we have, x of t is equal to sum or n equal to minus infinity to plus infinity Cn e raised to plus Jn omega t, okay. ये हमारा exponential Fourier series, okay. What is Cn? So we have जो Cn का वैल्यू है वो है Cn is equal to 1 over time period. So it is minus t by 2 to plus t by 2, or you can take 0 to t also. So it is x of t and here e raised to minus j n omega t dt. We can substitute here. इस समेशन के अंदर हम इंटीग्रेशन को सब्स्टिट्यूट करेंगे. So it is minus infinity to plus infinity sum of this thing, okay. So it is 1 over t, so minus t by 2 to plus t by 2 x of t e raised to minus j n omega t dt and bracket close. What is remaining term is plus j n omega t, ठीक है. अभी इससे होगा क्या, आपको जो रोल है इसका t का वो पता चलेगा, okay. So this is for, so this equation is valid for, this is valid for when t is, okay, fundamental time period, and x of t is periodic function. X of t is periodic function, okay. अभी we'll sketch the spectrum of this one. Fourier series का जो spectrum है हमारे पास वो कैसा है, तो magnitude of Cn, okay. So we have discussed in the previous lecture about how to obtain this magnitude versus phase spectrum of Fourier series. So it is minus omega plus omega, and for different omega we'll get this. So this component is a component hai, this is for C0, okay. So this is for n omega equal to 0, this is called C0. n equal to 0 हमें C0 obtain होगा, and these things will become smaller. So 2 omega, 3 omega and so on, and this one is omega, minus omega, 2 omega and so on. अभी यहाँ पर जो important point है वो ये है कि ये जो spectrum है it is not continuous. Okay, what is the important point to remember? Okay, magnitude spectrum जो है, magnitude spectrum of Fourier series is not continuous. Is not continuous. Okay, what is that? It is discrete. It is discrete. Okay, for values of n equal to what? Multiples of fundamental frequency. Okay, so it is n omega. n omega means what? n omega means n का वैल्यू चेंज किया, 1 omega, 2 omega, 3 omega, 4 omega and so on. ये सभी वैल्यूज के लिए हमें मैग्नीट्यूड मिल रहा है बाय यूजिंग, आफ्टर यूजिंग फूरियर सीरीज, है ना. एंड दिस इज द डिस्क्रीट स्पेक्ट्रम. ओके, लेकिन फूरियर ट्रांसफॉर्म जो है, हमारा जो स्पेक्ट्रम है फूरियर ट्रांसफॉर्म में, इट इज नॉट डिस्क्रीट. ओके, व्हाई इट इज नॉट डिस्क्रीट? बिकॉज अगर हमने ये इक्वेशन देखा, देखिए दिस इक्वेशन के अंदर इफ t टेंड्स टू इंफिनिटी, क्या होगा? इफ t टेंड्स टू इंफिनिटी, we'll write again here. So see here, omega is equal to 2 pi by t, and this here, okay, what happening? t tends to infinity. हमारा जो non periodic signal है, it is not repeating itself. Okay, when it will repeat we don't know. So it is said that t tends to infinity. Then what happens? अभी this equation में 2 pi by infinity, what will happen? Okay, so omega, okay, omega जो है, omega becomes continuous. Omega becomes continuous. Okay, it is not discrete like this. जो हमारा जो स्पेक्ट्रम है फूरियर ट्रांसफॉर्म का, वो कैसे है? कंटिन्यूअस है. So here x of omega, magnitude of x of omega और omega, ये जो स्पेक्ट्रम है हमारा वो है continuous spectrum. Okay, this is we are getting continuous spectrum for minus pi to plus pi. Okay, and x of omega, ये जो है x of omega is a function of continuous variable omega. Okay, it is shown here. ये जो omega है ये कैसा है? continuous variable है. Therefore magnitude भी क्या है? continuous है. Okay, so this is the difference between magnitude spectrum of Fourier series and magnitude spectrum of Fourier transform. Okay, झालं?